joining me on Fascinating Frontiers, episode 132. It's July 15th, 2026. Some fascinating developments to cover today. China's Tianwen-2 probe has reached a near-Earth asteroid after a billion-kilometre chase, raising the possibility that the target is a long-lost lunar fragment. The spacecraft has closed to within 20 kilometers of its target asteroid. It is now collecting spectra and rotation data during the approach. The primary goal is to test whether the asteroid represents captured lunar ejecta. These observations mark the first close-range compositional measurements of a potential moon fragment. Follow-up measurements will focus on surface composition and rotation characteristics. Next data releases are expected once initial spectra and imaging sequences are processed. The encounter supplies the first direct compositional measurements that could distinguish between captured lunar material and native asteroid origins. The Tianwen-2 data will test whether the body originated as lunar ejecta. Confirmation would reshape models of how material moves between the Earth-Moon system and near-Earth orbits. Now shifting to a high-energy detection in a very different regime. The Very Large Array recorded an off-axis radio afterglow after an intermediate mass black hole disrupted a passing star. The event provides rare evidence that such black holes can launch powerful jets. Observations constrain the mass range and accretion behavior of this elusive class of objects. Additional radio monitoring will track how the jet evolves over coming months. Radio observations captured the afterglow at multiple frequencies, revealing how the outflow interacts with the interstellar medium over time. We still do not know what fraction of intermediate mass black holes can generate such outflows or why some disruptions produce jets while others remain radio quiet. If the sun were compressed into a sphere the size of a large city, an intermediate mass black hole would still be 10 times more massive, yet occupy a volume no larger than a modest mountain range. When such an object passes near a star, tidal forces stretch the star into a thin stream that spirals inward, releasing enormous energy as the material crosses the event horizon. In the recent detection, that inflow apparently powered a relativistic jet pointed slightly away from our line of sight, producing the observed radio afterglow. The jet itself travels at nearly the speed of light and can remain detectable for months as it expands into surrounding gas. On a different note, orbital imaging has revealed striking surface features on Mars. The Mars Express orbiter captured a wide field of wind-sculpted dunes that appear metallic in tone inside Kaiser crater. These features formed over billions of years under persistent Martian winds. The image reveals fine-scale ripples across the dune field that trace past atmospheric patterns. Scientists will compare the new view with earlier orbital passes to track any seasonal changes. The observation adds another data point to ongoing robotic surveys of Mars' surface evolution. The wide-field view highlights how wind action has shaped the crater interior across multiple epochs. Crew members performed the first medical X-ray imaging during a spaceflight. The procedure demonstrates that routine diagnostic capability can now be maintained without returning samples to Earth. Equipment was adapted to operate in microgravity while meeting radiation safety standards. Future expeditions may expand the technique to monitor bone density and other crew health metrics. This milestone supports sustained human presence by enabling in situ medical assessment. The imaging run confirmed that standard radiographic hardware can function reliably inside a spacecraft cabin. NASA has selected 41 technologies for future Moon and Mars missions. The projects cover propulsion, life support, resource extraction, and navigation systems. Each technology targets specific challenges for sustained operations beyond low Earth orbit. Teams will advance the concepts through ground testing and prototype development. Progress reports will feed into broader planning for crewed lunar and Martian surface activities. The selections directly support the Artemis architecture and future robotic precursor missions. The funded efforts span multiple technical domains needed for extended surface stays. The Curiosity rover has moved through several distinct rock layers mapped from orbit in Gale Crater. Each unit shows different textures and mineral signatures that record changing environmental conditions. Atmospheric measurements continue alongside the geological work. The campaign will help reconstruct how the crater floor evolved over time. This phase of the mission builds on prior traverses by sampling a new sequence of mapped units. The rover is now examining contacts between previously identified strata to understand transitions in depositional environments. A new paper proposes new signatures as an intermediate category in astrobiology searches. The study argues that current searches focus too narrowly on either simple life or technological civilizations. It proposes looking for intermediate signs of intelligence that could appear after billions of years of biological evolution. The concept fills a gap between microbial biosignatures and radio signals. Follow-up work will identify observable markers that future telescopes could target. The approach opens a new search category between established biosignature and technosignature frameworks. The authors outline several potential observables that could be pursued with next-generation instruments. Measurements of more than 150,000 ancient stars show the oldest formed at the epoch predicted by the Standard Model. The result adds weight against certain proposed solutions to the Hubble tension. Precise age determinations came from combining spectroscopic and photometric surveys. Continued surveys will refine the age distribution across different galactic regions. The dataset strengthens the standard cosmological timeline within ongoing Hubble tension investigations. The large sample size allows statistical checks on formation epochs across varying metallicities and galactic positions. Researchers at Durham University identified a dense stellar nursery at the heart of a galaxy more than 9 billion years old. The structure offers a direct view of early galaxy assembly processes. High-resolution data reveal rapid star formation within a compact region. Further observations will test whether similar cores appear in even older systems. The finding extends the timeline for observing the earliest phases of galactic core development. The core appears embedded in a larger galactic structure already undergoing active assembly at that epoch. New measurements quantify the loose surface layer that covers the Moon. Thickness varies with location and influences landing site selection and resource extraction planning. The study combines orbital radar and surface sampling data. Future landers will test the maps during site characterization activities. These maps provide practical inputs for Artemis landing site evaluations and resource prospecting. The derived thickness values differ systematically between highlands and mare regions. 4 white dwarfs were identified through their gravitational influence rather than direct light. Each object is denser than typical white dwarfs, yet remains invisible in standard surveys. The discovery expands the known population of nearby compact remnants. Additional radial velocity monitoring will determine their exact masses and cooling ages. The detections increase the census of nearby white dwarfs available for detailed follow-up. The companions are red dwarfs whose orbital motions revealed the hidden dense objects. A new mission concept called Skyfall would send 3 aircraft to survey regions inaccessible to rovers on Mars. The aircraft would map climate history and identify landing sites for future human missions. The design builds on lessons from the Ingenuity helicopter. Concept studies will assess power and communication requirements for extended flights. Skyfall would extend the robotic exploration program by adding aerial reconnaissance capabilities to Mars surface studies. The aircraft are envisioned to operate at altitudes that permit broad regional coverage in a single flight. The Artemis II crew met the European teams responsible for the Orion service module at ESTEC. The visit covered integration status and operational procedures. Data from the meeting will inform final checks before the mission. The service module remains a critical element for life support and propulsion during the flight. This review advances the Artemis architecture by confirming hardware readiness for the crewed lunar trajectory. The astronauts examined interfaces that will supply power, propulsion, and thermal control for the flyby. NASA astronaut Anil Menon and 2 Roscosmos cosmonauts entered the space station laboratory after docking for Expedition 74. They will conduct experiments during an 8-month stay. Daily updates will appear on the NASA Space Station blog. The The crew is scheduled to return in April 2027. The arrival continues the cadence of crew rotations supporting ongoing commercial and international operations in low Earth orbit. The new members join an existing crew already performing a range of science and maintenance tasks. Object 69,999 has been assigned to a previously uncatalogued piece of the 1958 Vanguard 1 satellite. The fragment now carries the international designation 1958-002D. The assignment marks the last entry before the catalog numbering system rolls over. Analysts will continue to track the object's orbit with existing radar assets. The cataloging step closes the pre-rollover sequence for debris from one of the earliest orbital missions. The piece had remained unnumbered despite decades of orbital tracking. New orbital data and mission concepts continue to refine our picture of both nearby and distant worlds. Keep an eye on the next round of Tianwen-2 spectra releases expected in the coming weeks. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. First Principles Daily, reasoning from raw materials, not analogy, on the breakthroughs that actually cut cost. Find every show free at neranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on neranetwork.com. Scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.